So I let you start, Clyde.
Well, thank you. Thank you for having me today to talk to your association, your peer community. It's really important that we get together, exchange ideas, and share experiences. As indicated by Matthew, I am the senior manager of critical environments Rogers. I look after a very broad portfolio in a very large company. And it consists of quite a variety of properties, City TV, the NHL studios, 680 News, Shopping Channel. I support our network with critical power and cooling as well in some of our facilities. So very broad portfolio and scope that I look after. And, we'll go through some stuff today, and I hope that we can, create greater awareness of uptime in our mission critical environments that we tend to looking after more and more these days with big data and so forth. So with that said, I'm going to move into a few slides that kind of talk about commissioning from my perspective, being an owner operator. Okay. Bit of an agenda here today. We'll just cover a few things here. We only got 30 minutes on a very, very big topic. So, we want to talk about facility resiliency, developing a higher perspective on critical environments, commissioning on obviously energy from our perspective. So let's keep going here. Okay, commissioning. It's really a process designed to test both individual components of a whole system to ensure they operate as designed. So you can imagine our infrastructure being power, cooling. It's quite large. It consists of a lot of moving parts. It sometimes sits idle when it's not called to an emergency to support our critical environment. So commissioning is so important to critical environments. We'll talk more about that as we go on. The next one here is commissioning is the official beginning of the facility handover from the contractor to the people who are going to run that facility. And again, that is so important that we have a proper handover process developed and to help our FM team thrive and set them up for success. The other one is commissioning is just not for data centers. It's important that we commission all customer-facing equipment, and that it's going to work as we planned it, as it was designed, of course. Recommissioning takes place after any major repair of a critical system. We need to make sure if we do an upgrade or do a repair that it's going to function back with the rest of that equipment properly. Why is commission important? It's a unique period in time to verify system performance as designed without risk to, your critical loads, in fear of taking down mission critical equipment. So it's that unique opportunity that we don't get very often, and it's a good time to test. Okay. The other one, identify critical infrastructure equipment that can fail. We want to get in front of that early. It could be a simple programming change, or we could lose a generator, could blow up. I've seen that happen. Other one here is a key opportunity for maintenance and operation teams to get that additional hands-on experience. If our FM team isn't working with our commissioning agent, something's wrong. They both complement each other, and we want to set our FM teams up to succeed. Very important step in the commissioning. The other one is the opportunity to verify detailed written procedures. MOPs, SOPs, EOPs, these are very important tools in our toolbox that we want to create in that commissioning phase to help our facilities people and to work with them closer and bringing that facility into a live production environment. Because we do repeat things over time, and we need those procedures to help them. And we'll talk a little bit more about them later. Some of you may not know those acronyms, but we can get to them. They're important to know. Very important in the critical. They're used every day in our world. Only opportunity to test the facility limitations in that conditioning phase, very important to understand the limitations of the equipment, make sure it's working within those design parameters. So that is key for us as well. We'll move on here. I'd put this into 5 steps here. Broke it down a little bit because in the world of commissioning critical environments, very complex. It's not a simple thing. I'm an Uptime Institute member. We'll talk about the Uptime a little bit more, but they're very similar to your association in the critical environment world. It's a great organization, taught me a great deal, and we'll talk more about that later. But let's go into step 1 here. Factory witness testing. Factory witness testing is very, very important to a critical environment for a number of reasons. It's usually outlined in the testing protocols in the bid submission by the engineer. We usually have an engineer present or a commissioning agent or a representative of the owner when we're doing that factory witness testing, and that could be a generator, that could be an ATS, it could be a number of things, transformers, any big primary piece of equipment, chillers. We want to make sure by the time they get into that critical environment, they're working, they're in good order. Step 2 is acceptance. Acceptance is when it comes to site, we want to make sure it hasn't been damaged, it's in good shape, all the parts are there, everything's there to get that installed in place. I've had equipment show up without parts, damaged. Like a good example is I had a cooling tower show up, it was hit by a tree. There was no structural damage. We got a great rebate. I asked them to extend the warranty on the tower. There was no concern, so it was a win-win for us all from that standpoint. Pre-function testing, step 3 here. This is really when we get the equipment installed, we want to make sure it meets the standard specifications and it's in place before we go into step 4. We'll get into step 4 here, and that's where we start reviewing the performance testing, and we're starting to group all the equipment together in that functional test period. And then step 5. Step 5 is really bringing it all together. It's a bit of the grand finale when we get in the testing environment. And step 5 is basically what we do is we do simulation testing. And the main part of that simulation is excuse me, here, I just need a drink, is simulating loss of power and putting that critical infrastructure to work. So you've got generators, chillers, switches, switchboards, automation, and checking and making sure that all those systems that have been integrated, those multiple paths, are working, communicating, is the most important step in that functional test process. Okay. A lot of people get nervous when we do it. Sometimes I get asked, does your boss know what you're doing? Stuff like that. So it's interesting. A lot of fun, a little bit of stress and some late nights, but it all comes together with a proper commissioning engineering team. It's all about team. This is factory witness testing. Here I'm at the manufacturer. You'll see me on the left there. I'm with the guy who built this board, and we're about to put this double-ended switchboard together. Okay, this is what's called a concurrent maintainable switchboard. So it's double-ended. So we can take one side of the board down and work on the other side without turning the power off to mission critical equipment. So in the mission critical world, you'll hear us use concurrent maintainability. Okay, that allows us to service equipment, repair equipment, do modifications, add on tie-ins, and so forth. Okay, because once you go into a live production, you can't be turning those loads off. There's no going back. So we've got to design, we got to look down the road and make sure we get it. So we went to this factory, set it all up, tested the scheme, tested the breakers, and a number of the breakers failed. That's why we're at the factory. We're testing, we're validating that when it comes and gets into production and we got all the crews there and we go live, it's going to work, right? We don't want to lose time in our schedule. Time is important. The picture on the right shows the switchgear all together, nicely put together, nicely completed project. This is another great example of factory witness testing that's overlooked with transformers. Okay. This is at the manufacturer. We got there. We did an isolated resistance test. The transformer failed. We had to detank that transformer. We got it on the ground. It still failed the testing. So the transformer was making contact with the chassis that holds it together. So, good thing it didn't show up on site or we'd have problems. And when we ship this, it comes on transport truck, this big transformer. Before that transformer comes off the truck, we test it again, okay? Because they do get damaged in transport. So you don't want to get in that situation with the heavy costs associated. It's always doing testing. Testing is something I believe in. This is an interesting one. In our critical environment of uptime, we rely on batteries. There's a lot of different batteries out there. Designing a battery room with proper climate is key. If you get yourself in a situation like this, you want to understand the type of battery you're dealing with, the environment that is required for that type of battery. There's a lot going on with lithium. I'm still old school. I like the old lead acid. It's my preferred gold standard still. But they all have a good application too. That's not to say I'm not installing lithium, but we are. But as we know, there's a lot of fires associated, a lot of things you need to know. But back to climate, you'll see this unit is blowing on the batteries, and that's a big no-no. Not good for the batteries, blowing cold air. And up here, you'll see there's an exhaust louver where we found an exhaust fan running around the clock and keeping the room in a negative pressure, pushing a lot of air. There's more than one vent here too. These rooms have a lot of ventilation because, open lead acid batteries developed hydrogen. Things you got to be careful about, can be quite complicated. Just kind of an interesting slide here. I like this because, ambient temperature is key on batteries. And if you have the right temperature, you keep them there. They'll last a long time, 20 years. Once you get warm, rooms, you lose climate, and you're in the hot temperatures for a long period of times, you could run into some problems with your batteries. So really work closely with your battery manufacturer. Understand what you're dealing with. RTUs, we have RTUs everywhere. They're big energy users. We have them running around the clock in our critical environments. Not my favorite system, but we just have them everywhere. You'll see here on the left here, there's one on the ground. Last May, we had the big windstorm roll through, and it blew off. Wasn't fastened down. So, when we're commissioning equipment, we've got to make sure we're checking things, make sure things are fastened down. A lot of people don't like to get up on the roof, don't want to check things. Make sure things are fastened down. There's one here. It's an upgrade when you order an RTU, and this is a bit of a legacy thing, going back in the day where, they didn't think to order hail guards, and I get up on the roof and I see the damage from hail. Good heavens to Betsy. Not good on performance. And you'll notice how close it is to the ground, where this one's way up. This is up nice and high. That's good. You want to keep the coils clean. What else do we got here? Digital scroll compressors. When you got a lot of RTUs, you really got to pay attention, because they're getting complicated. There's a lot to them. Not everybody necessarily understands, but we got a situation here where digital compressors are cycling off at high, intervals, and consuming a lot of energy. And it also puts them into a situation where they're overheating, and the internal cooling and loss of oil is impacted by high cycling on and off. So that's something that's quite concerning. Got to watch out for. And this system was commissioned quite some time ago, and we come across these problems. And these gas valves, here's another example, is these are two manifold gas valves. And when you're commissioning a unit, it's important to make sure you've got your manifold pressures right. Check your inlet gas pressures on low, high fire. Make sure you got the right manifold required pressure for efficient operations. We're all trying to do our best for climate change, energy. It really gets impacted, and proper commissioning of these RTUs is key. Okay. Make sure you got a good filter in there as well. Okay. After learning and kind of figuring out all this stuff with RTUs, and we really need to take some steps back and look at pre-functional checks with equipment, with what we're doing. Make sure that the mechanical controls are working, your economizers, who's checking, stuff like that. Number 2 here, monitoring. Use your BAS system. Monitor, your unit if you can get cycles or temperatures. It's a great tool to help you find those baselines on where things are drifting and going. 3 is more functional testing with your vendors and whoever, making sure that things are working properly, because we find a lot of gaps with RTUs. And yeah, being visible, getting up on the roof, boots on the ground, checking these things, really, really important. How are we doing for time here? Cooling towers. I put this in because galvanized cooling towers, passivation, something that's not necessarily done or missed in the industry. This slide here shows a brand new galvanized metal. And if you don't do passivation, you will get white rusting. on it, and that's what white rusting looks like. And this here is when a cooling tower hot deck has been properly pacified to prevent corrosion. It's a chemical process. They lay down a zinc layer in the solution. This is something that's recommended by the manufacturer on treating and seasoning the metal on cooling towers, but no one knows about it. Probably the big problem is time. It can take several weeks or months to do a proper passivation on the metal on cooling tower. This one here, this is out of a critical facility. I only had one generator. We had to bring in a mobile unit. And I've seen this before, and I wanted to talk about it today because it's glycol. If glycol is not, you don't have the right glycol, you're not monitoring it, maintaining it. You can see here, down here on the right side here, the gasket gets affected by glycol when it goes south. You'll see the 1 and 2 cylinder at the front here, how they become rusted. Okay, and I'll go to the next slide here, and we'll look at the exterior wall of the cylinder, and you'll see the corrosion on here. And this happens when glycol is starting to go bad. You'll start to see these symptoms. This isn't an oil filter. Everyone thinks this is an oil filter. No, it's not. When you test your glycol, you've got to make sure you've got the right filter to filter the glycol. Okay, something a lot of people don't know or is misunderstood. We're losing our great mechanics. They're all retiring. And I'm seeing gaps across the board on experience and knowledge and the level of care of mission critical equipment. Corona transformer. Just because you get a new transformer doesn't mean it's going to be working good. A lot of times our commission agents, they're not around 12 months down the road to kind of find out, hey, how are things going? Were there any problems? Did anything surface? And sometimes we do have 1-year walkarounds after a project. That should be in your spec. But here, Corona is, this transformer started tracking and it developed Corona. And, this is where ultrasonic testing is important, making sure that transformer is in good health. Again, uptime is paramount. So some protection there, oil analysis. We start up a new transformer. We're checking the oil too to make sure it's good. Just because it got commissioned doesn't mean we're checking it. Want to make sure that it's in good health. This is a bus duct, major facility. Bus duct was installed. My electrician came to me and basically said, we got a problem, that this buck was live in production and it hadn't been clicked in. And, that's not good. That's quite concerning. So he brought it up, and sometimes our facility people may be intimidated or bullied by speaking up when they see a problem. And this is where our commissioning team, and they need support, right, to support the facility people when sometimes contractors don't want to play nice. I thought I'd throw this in. I've had a lot of brass valves fail recently, and I don't know if it's a manufacturing or if it's over tightening, probably over tightening, and the quality of the brass has perhaps changed over time, but seen a lot of these lately. We'll be going to stainless steel. I just thought I'd throw this in. Even though we have redundancy in some of our systems, it's still very costly and painful to have to make these repairs on a new system. Threw in here a little bit of a little case study here, and kind of my portfolio and size wise. You know, we've got a portfolio here that's over $30 million. Set a goal of saving 5% on our utilities. You know, that could have possibly end up in 1.5 million a year in savings. So, you know, commissioning so valuable to us on retro commissioning and so forth, and getting our systems working optimally in the critical environment worlds. As you know, these 5G servers are generating more heat and so forth. Really important that we can find and take advantage of this and set some goals with our FM team. And really, bit of an overview here, best in class. Facility resiliency. How do I keep uptime? How do I keep our customers taken care of here? So there's kind of 8 steps here that we put together on what that looks like and what we strive for here. And good planning, impact assessment. Obviously, we start there. Working with our engineers who know our systems, work well with us, understand us. Strong project management to help us deliver these projects. It's vital. Testing and commissioning. I mean, guys, where would I be without commissioning? I've seen it evolve through my career, and if we are not commissioning, it puts our facility people in a reactive culture. We need commissioning to help us greatly. Education and training. You know, we talked about plug tests and commissioning being vital to that continuing process. I love the plug test because I get retrained at the same time. Documentation, proper handover documentation, both hard and soft, vital to our teams. Operation and maintenance, it's key to developing those proper periodic maintenance schedules, having proper CMMS, very important. And now the big one is energy, as we all strive to get our GHG under control, and reduce our energy is becoming very big, and especially in the commissioning world, we're gonna really see commissioning grow around energy. So those are, you know, best in class facility resiliency processes that you know, I speak to and swear by, and the people I need to make it happen. And the Uptime Institute. Now, I'm a member of the Uptime Institute, and this is out of their incident report database. The majority of all outages are caused by human error, resulting in poor management decisions. So true. I think we're down to about 70% of all outages are, you know, human error now. It's come down. The Uptime Institute has been able to work with our peer community, get more involved, and help us bring that down. The Uptime is very much like your association. It's a global peer community. They have wonderful tools, wonderful programs. Taught me a great deal. So grateful for their teachings. And I think we're out of time. I know I've had to fly through this. It's 12:33. And Matthew, I think that's it. How is that?
It was great. We had great content today, Clyde. Thank you very much. And we'd be ready for some questions now. So if you feel free to open your mic or type some questions in the chat as well. But again, we're very happy to have the owner's perspective. Say someone put this in the chat. It's totally true. So thanks again for stepping up and taking time with us today.
My pleasure.
Perfect. Thank you.
Hey, Clyde, Clyde, I've got a question.
Sure.
Jim Blanchard.
Hey, Jim.
I'm involved in a lot of the stuff you're talking about in mission critical facilities. And these factory tests we're talking about, how do you deal with how do you deal with a failure at a factory test? Because the construction schedule is so dependent on equipment being delivered in a timely manner and in the right order. Otherwise, it can impact the schedule tremendously. So how would you deal with let's say a generator issue that makes a generator difficult to accept? And we know the lead time on generators is very long. So how would you deal with that in one of your facilities in a factory test?
Yeah, so that's a great question because the world has changed. Post-pandemic, delays are killing us. We've just accepted some new chillers that we didn't get. I got 2 brand new 670-ton chillers that I didn't get to factory witness test because of the pandemic. So they're in sight. But, when you're at the factory, you're dealing with the subject experts. Okay, this is where they built the equipment. So their turnaround time is quite good. You're dealing with a lot of the big brand names. They're very respectful. They know this is a serious piece of equipment going in. They know it's an important customer, and they'll do their very best for you. And I've never had any delays at the factory that were too bad. We've been very fortunate. And that's also, when you talk to your engineers and people in the peer community, different brands, there are companies that specialize in certain equipment that will turn around pretty quickly. So we've never had that problem, but it's a good question, and I'm sure it's going to come up for people.
Thanks.
Thank you, Clyde. So what I'll do is I'll ask people to raise their hands, and then we'll just go in order of the questions. But before we get there, Fuad, you had a question. You raised your hand, and then you canceled it.
Yes, I do. I would like to thank Clyde for this presentation. We've learned a lot, actually. Me as a commissioning agent, I do need to see more of these. My question is purely technical for the transformer. How did you find out that it was faulty? What is your procedure for testing it on the factory?
That's a good question. And so what we did was we asked that the core ground leads were brought out of the terminal blocks. Okay, and that allowed us to do those tests. But it's a very simple insulation resistance test, right? We just want to make sure it's not grounded. Okay, it's that simple. Believe it or not, it's something that's overlooked and not understood.
Wow, that's really simple. And for coincidence, I do test the grounding with the neutral and with the 3-phase whenever I have a chance to do that. Thanks, Clyde.
Yes.
Awesome.
Thank you. Thank you. For next, we'll go to Permanent. You have a question for us, please?
Oh yeah, thank you very much for calling on me. So, well, first of all, I'd like to thank Clyde very much for he was able to bring this presentation right down to the bottom. I have learned quite a lot, and one of the biggest advantage I have here today, I have the privilege of working with Clyde on many projects across Canada at Rogers. So I know this guy's background, what he brings to the table. I mentioned it in the chat. He have developed one of the best critical environment handbook I've ever seen. So I want to thank Clyde again for bringing this thing out, and I'm very hopeful he will continue on with the Uptime Institute and doing a lot more presentation as we go. He is really a critical environment chief, right? So thanks again, Clyde.
Oh, thanks, Brian.
Perfect. Thank you. Clyde, I've got a couple of questions actually as well. Great presentation. Thank you so much for taking your time going through some of this stuff with us. one of the biggest questions I had is, what is Roger's approach when it comes to mission critical commissioning versus like regular building commissioning? I know you mentioned some of the stuff that it's sort of different for us is one being the witnessing the actual factory testing, and the other one I really liked is maybe you could elaborate a little bit more on the pool test and to what extent do you actually go through, like you did mention the building automation system, but like do you go to security, fire alarm, and all that stuff as well during the pool test?
So yeah, definitely all the systems in the building are going to be responding. When you do a power simulation test, they're all going to respond. And when we do it, we have a team on site. I like to have my commissioning agent there. I bring in all the FM team. I bring in contractors, and they've all got a role, responsibility. And they're monitoring their equipment. And, we got the guy looking after the generators. We've got the guy looking after the switchboard. We got the chiller mechanic there. And it's a very complex test. And it's very high value, as I said, for training and developing the staff. To help them relearn the system and what it does in that mode of operation. Knock on wood, we don't have a lot of utility outages at our core sites. But there's a lot of moving parts, and it's very intimidating. It takes some time to get comfortable with all this moving parts. And it's a wonderful test for us to perform. I mean, it is a form of commissioning. When we do it, we're going to check it, and it's high value. I mean, if you're not testing your systems, you're leaving your door wide open for failure. Okay, and we know that from experience. Sadly, it does happen. And it's quite important.
Perfect.
I hope
Thank you. So just touch base on the first part of the question. So in a typical commissioning, like what are the things that really stand out when it comes to mission critical commissioning versus the regular commissioning of?
Yeah. So commissioning is I don't have under my care and control any tier 3, tier 4 data centers, and that's referring to the uptime topology and their standards. They have a whole separate standard. They've trained me, they've taught me. But when they come in to do if you have an uptime certified data center, because you're marketing your services, that's what people want to see when they're putting stuff in in their data center and your marketing is, hey, these guys are uptime certified. If I was a customer and I was going in a tier 4 data center and their uptime, that's the top of the house. But for us, some of our stuff is not necessarily it's mission critical, but we may not have a cloud in that environment, but we're checking all the boxes. We're doing testing in different scenarios. And we want to make sure that the system is going to perform under those conditions. So we work closely with our engineers and our commissioning. We'll work together and write that script, with my commissioning team and engineers. So it's also done site specific too on what we're doing as well. But when you're doing the full plug test, it involves every piece of component equipment. Okay.
Perfect. Thank you. Mike has a question. Go ahead, Mike.
Hi, everyone. And hi, Clyde. And thank you for your eloquent presentation, which I really found to be interesting and informative. My question follows on the last comments you actually were making about the way you carry out your commissioning. I want to ask you, when you are contemplating and when you're contemplating and designing your new projects that are going to be complex and will include one or more pieces of critical equipment, do you build into the design, right at the design stage, the complexity of the commissioning activities that you want carried out in your project? In other words, do you have your designers include in the drawings and specifications details of the requirements of for commissioning your project, so that the contractor and other associates know from the beginning what the end is going to look like in terms of your commissioning needs?
Yeah, so that's a good question, and I didn't have time to go into that, and I was going to. 30 minutes is not enough time to go into the critical environment world and talk about that integrated capital planning that you've talked about. And we do our very best to follow the guidance of the Uptime Institute on that strategy. They lay that out very nicely. And that is very complex. So, it will include the OPR, will include MOPS and SOPs and EOP. And as the project goes through its phases, we're trying to hit all those important items, because as you and I know, at the end of the project, we ain't gonna have time to circle back. You got to get in front of it. So your thought process is bang on that. And our MOPs, for example, what we call hard MOPs, our methods of procedure, we try to nail them down to help our facility people run the facility afterwards. Our standard operating procedures, we'll create those. I get a lot of my commissioning team to help me with those at that phase. Our emergency operating procedures, we want to touch on them as well. Okay, so we have them, and they're there. They're in that toolbox, and that toolbox is ready as the project goes through its phases, and we get to that delivery and handover. I hope I answered that for you.
Yes, you did, Clyde, and thank you again.
Thank you all. Do we have any other questions? I see a lot of compliments in the chat part, but I don't see many questions in there.
Yeah, so a lot of people are intimidated, I find, by critical environments and maybe reluctant to ask questions, or it's something they're not familiar with. There's no bad questions.
I see one in the chat, Clyde, that Fuad is asking, how can we get a copy of the handbook that Berman mentioned? So I guess you should send us a link on how we can get a hand on this handbook.
Yeah, that's something I haven't published publicly. That's an internal document that I've written.
It's too bad for us,
our team. On these things. It's such a vast topic, critical environments. I mean, 30 minutes is really tough, guys, but I condensed it as much as I could, and I took a lot of stuff out because just didn't have time.
Yeah, okay. Well, if we don't have any more questions, then I'm gonna do two things. I wanna invite the attendees to provide the suggestions for future webinars. And if you want to speak, feel free to contact myself or anyone on the board of directors of our chapter. And lastly, I wanna on behalf of all the attendees here and also our chapter, I want to thank you very much, Clyde, again, for this great presentation today. So thank you so much, and stay tuned for the next webinars.
Well, thank you. Thank you so much. I thank you.
Thank you. Have a nice afternoon.